So as part of our analysis, we also looked at modelling the runoff characteristics, the stormwater and runoff characteristics of the developments, the different designs. So to do that, we used the music model, which is the model for urban stormwater improvement conceptualization. And our goal of this modelling was to try to understand what the frequency and quality of the water that ran off the property was going to be to the local Little Stringy Bark Creek, and to try to minimize that impact, both in terms of pollutants and frequency, trying to match the pre-development frequency. So the modelling was conducted in 3 cases. First case was the base case, so traditional layout with no water-sensitive urban design implementation. The second was the option 1 layout, and that had some water-sensitive features, but it was still quite traditional. And then option 2 was the water is life case, and it had full water-sensitive urban design implementation, swales and rain gardens and retention basins and all the different measures that we employed. So the first goal was to attempt to do a calibration of the data. Calibration was trying to match the flow runoff characteristics that were observed, that are currently observed at the site, using the measurements that are currently there, and trying to match the flow characteristics of the model with those observed so that the model reflects the true values. It's a very difficult process, and it doesn't always come out with very good results. But the way we implemented that was that we manipulated some of the parameters, so maybe soil moisture, different parameters, and tried to match the runoff characteristics that were at the site. And to do that, we changed a little bit, checked the coefficient of determination, the R-squared, and also the Nash-Sutcliffe coefficients to assess how close it was, and also view it just visually to try to see if it matches the peaks and the troughs, and did that over a day and hourly, daily, and then yearly time cycles. So we found that for the traditional case, this is the general model. So you've got the outline of the development, and you've got the different pathways through which water will flow. So we tried to match the land use. So land use is generally in 3 different types. So the natural catchment, housing catchment, and the lot subcatchment, and also the road area. So obviously those different land uses will have different characteristics, so we modelled them based on these land use pockets. And yeah, it was just basically traditional, some swales, some rain gardens, a little bit of stormwater capture, and all other just regular concrete infrastructure to convey. So option 2 is the water is life model, and you can see there's increased complexity here, but the reason that we decided to go with this increased complexity over a more simplistic design was that I wanted to make sure that the length of the swales were adequately represented, and that the loads were adequately represented in each area. So if a certain area was having a higher load, we could restructure the development and try to maybe include that in a different stormwater runoff area, so to reduce the loads and minimize the risk of flooding. So it contained swales, wetlands, rain gardens, and retention basins, and also the reduced rainwater demand on site to increase the water save. So generally we found that that option 2 had significantly higher reductions in runoff volume, the suspended solids, phosphorus and nitrogen, and gross pollutants as well. And they met the option 2, both option 1 and option 2 met our reduction targets. Option 2 is a lot more sustainable in the long term and represents a lot better environmentally friendly option, and also cost-saving option for the population. So, to assess how the population was going to respond to our designs, both option 1 and option 2, as an input to the triple bottom line model, we used a community feedback forum. So part of the community feedback was consultation, so we sent out a form to different colleagues, friends, family, and tried to gauge if they were moving to that development, what would they want to see, what would they need, what would they want, what would their requirements be. So we wanted to generally understand willingness to embrace water-sensitive urban design features. We wanted to assess what the likelihood of maintenance of those features would be. Rain gardens and rainwater tanks there do require some maintenance. And we just wanted to get an idea of general thoughts, feelings, needs and requirements to try to understand whether the development, option 1 or option 2, would be more accepted by the population. So the group was quite small. There was only 16 people, but varying ages and backgrounds, so there's a benefit there. 11 simple questions, some yes, no, some hours per week, some rating scales. And in general, there's an example of a question here. Would you consider paying extra for the following features? And we went through house construction that reduces energy use, collection reuse of rainwater, etc., and we got the feedback in terms of a rating score. So in general, from all the questions, it seems that participants value the water features, whether they're water sensitive urban design features or just water features. They really like public open space and access to public transport and parklands is also an incredibly important component of that. So after finalizing the triple bottom line and all the information that fed into that unit, costing, community feedback, all the rest, Consult Consulting has decided to recommend option number 2, the Water is Life option, to be taken to the design phase. The reason for this is multifaceted. Firstly, it's the only option it was rated highest on the triple bottom line scale, and also was best in terms of community response. But additionally, it meets all the client objectives and the objectives that were met in the community feedback. It protects the Little Stringy Bark Creek into the future by a sustainable output of runoff frequency and quality. It increases livability and the beauty of the neighbourhood, also increases economic return on investment, and also reduces operational costs for the community. And yeah, the community really values those water sensitive design features. So in addition, it is recommended by Consult Consulting that that option 1 also continues to the design and feasibility stage, to be used as a backup, and so that the client can pick and choose which elements from both that they would like, because both do meet all the minimum requirements. Consult with additional experts in the field, the geotechnical experts, construction, marketing, financial consultants, and find out from different perspectives whether the information that Consult Consulting have obtained is relevant to the client's perspective. Also conduct further community feedback and engage them in any decision made about the community. So try to involve them in all the decisions, so that if our community feedback has missed some important goal or requirement, then that will be fulfilled. And finally, investigate alternative technologies. So tank talk, other rainwater gardens, more efficient systems, renewable energies, green walls, green roofs. It wasn't the focus of this report, but these technologies have the potential. There is a risk involved, but these technologies have the potential to benefit us, benefit the development. So thank you for your time, and I just want to thank all the members of Consult Consulting for coming together and getting this together, and thank you for listening. And would you have any questions?